We are going to continue using unit multipliers today. Specifically, we're going to start using more than one. We've kind of thrown a few of these in there every once in a while in problem sets, but now we're going to concentrate specifically on them and why they're necessary. All right, so looking at problems B through H, for which problems will we need 2 unit multipliers, 3 unit multipliers, and how do we know? Okay, so go ahead and glance on your note sheet, and I'm doing the same right now. Let's specifically look at problems B through, just B and C right now. Look at those. They are area conversions. And since they're area conversions, we're going to need 2 unit multipliers. We'll see how that's done when we actually get to those problems. Okay, now what about problems D and E? Those are volume conversions. And with volume conversions, we're going to need 3 unit multipliers. With area, there's two dimensions that make up area. We need to change both of those. With volume, there's 3 dimensions that make up volume. So we need to change all 3 of those. Now, problems F through G. I'm sorry, F through H, actually. You know what, I wrote G here, but I'm going to change that to an H in just a second. Problems F through G or H are rate conversions or rate problems where both units need to be converted. So it's going to take us at least 2. You know, we don't know really before we start. Maybe we need more than 2, but we're going to need at least 2 unit multipliers to convert those rate problems because we have to change both the distance and the time. Again, I said I'd change this here. It should say H. Okay. So we're going to use multiple unit multipliers to perform these conversions. And like I said, these are area conversions. So what we've got here is 9 square feet. And I could write 9 square feet as in 9 feet squared, or I can write feet times feet because that's square feet. That's where the feet come from. Okay, the square feet comes from. Now I'm going to convert this into square inches. Now I do know that there are 12 inches in every foot. And that is a unit multiplier. And when I do that, you can see how one of the feet would cancel out. Now what I got to do is do this one more time, 12 inches in every foot, so that I can get both of the feet in square feet to cancel out. That comes out to 20 cents per minute, I believe. Okay, next one we're going to do 10 yards per second. So let's start off by just writing that 10 yards per second. And we're going to convert that into feet per minute. So first of all, I know that there are 3 feet in every yard. And that'll get rid of yards. So right now, if we stopped and just did 10 times 3, we'd have 30 feet per second. But we don't want feet per second, we want feet per minute. So I'm going to multiply by the fact that there's 60 seconds in every 1 minute. And again, you can see how my units cancel out. So I'll do 10 times 3 times 60, and I'll have feet per minute. 1,800 feet per minute is equivalent to 10 yards per second. Okay. One more. 1 gallon per day, and we're going to convert that into quarts per hour. Okay, first of all, here's the rate we're given, 1 gallon per day. I want to get this into quarts per hour. So there's 4 quarts in every gallon. Should have that memorized by now. And there are, every 1 day has 24 hours. So see how days cancels out. And we're going to be left with quarts per hour here. So 1 times 4 divided by 24. 4 divided by 24, that's a fraction. So how about we just do 4 into 24 6 times. So it's 1/6 of a quart per hour. Okay, so the rules of simplifying fractions still apply here. Multiplying fractions too. 4 goes into 24 6 times, so it's 1/6 of a quart per hour. That's it for today. We'll give this a try tomorrow. See you then.